In this video, we are going to discuss 2011 A-level combined maths. Actually, it's pure maths. Pure maths part B, question number 11. We are going to discuss question number 11, which is basically consisting of quadratics. The first part is going to be from the lesson quadratics, and then the second part is going to be from remainder and factor theorem. Remainder and factor theorem. Before starting the video, if any one of you are interested in joining the live class for whichever batch, please contact this number 719-830-554. Okay. Question 11a. Question 11, they are telling, let alpha and beta be the roots of the quadratic equation ax squared plus bx plus c equals 0. Now you have ax squared plus bx plus c equals 0. This is a quadratic equation where the two roots are alpha and beta. They are telling you that a, b and c are real numbers. They are asking, show that alpha and beta are both real if and only if b squared minus 4ac is greater than 0. Roman 2, purely imaginary if and only if b is equal to 0 and ac is greater than 0. Let's see. In order for you to complete this question, Roman 1, first of all you need to complete square by completing squares. Let's do it here. Ax squared plus bx plus c equals 0. Take this c to the other side, you will have ax squared plus bx equals minus c. Take a away, divide everything by a. X squared plus b over a, x equals minus c over a. Now put a bracket. X means x, plus means plus. B over a is the coefficient, take half of it. It's going to be b over 2a squared. Put minus. Square of this whole thing. B means b squared, 2 means 4, a means a squared. This is equal to minus c over a. Subject this, take this to this side. What will you have? X plus b over 2a whole thing squared equals b squared divided by 4a squared minus c over a. Now take the common denominator, 4a squared here. It's going to be b squared minus 4ac. Here it's going to be x plus b over 2a whole thing squared. X plus b over 2a, if you root this, this is going to be plus or minus square root b squared minus 4ac divided by 4a squared. Now the denominator 4a squared is a complete square. So you can take x plus b over 2a equals plus or minus square root b squared minus 4ac divided by 2a. Take this to this side, x equals minus b plus or minus b squared minus 4ac divided by 2a. Okay. Now this x is actually root. X is the root, which means x equals alpha or beta. Basically alpha or beta, which is alpha or beta is x. Based on if you put plus or minus, it will give you alpha and beta. Okay. Now the question is Roman 1, to prove that alpha and beta are both real if and only if b squared minus 4ac is what? Greater than 0. So x is real. Now this whole thing will become real. Now everything here is real except whatever that is inside the square root, because the moment the b squared minus 4ac, whatever that is inside the square root becomes negative, this becomes an imaginary number. So x will become real if you have this term to be real. Whatever that is inside the square root should be positive. B squared minus 4ac must be positive. Therefore alpha and beta are real write if and only if b squared minus 4ac is greater than or equal to 0. 0 also works, no problem. Okay, that part is done. Then Roman 2. As for Roman 2, they are asking to prove that alpha and beta are purely imaginary if and only if b is equal to 0 and ac is greater than 0. Okay. Now, when you consider complex numbers has two parts. You have the real part and you have the imaginary part. If you don't have a real part, if the real part is 0, then the number that you get is purely imaginary. They are telling you the root that you are going to have should be purely imaginary. Okay. Okay. Then what is the root? Root is basically x. X equals minus b over 2a plus or minus square root b squared minus 4ac over 2a. Now this part is the real part. This part would be the real part. Since this part can be real or imaginary, this is going to be the imaginary part. This part is imaginary part. Okay. Now a can't be 0. Why? A is in the denominator. Okay. If you want this particular root to be purely imaginary, real part should be 0. Therefore, b should be 0. B must be 0. Okay. Now, when b is equal to 0, this becomes purely imaginary. But there is one more condition that you need to prove. Okay. Now, if you want this to be purely imaginary, whatever that is inside the square root should be negative. Because the moment whatever inside the square root becomes positive, it becomes a real number. So, b squared minus 4ac must be negative. Now, b is already 0, which means b squared is also what? 0. Minus 4ac is negative. Divide both by minus 4, ac will become positive. Therefore, roots are purely imaginary. I'll write it here. Purely imaginary if and only if b equals 0 and ac is positive. Okay, second part is also proved. Finished. Then they are telling you find the quadratic equation whose roots are a alpha squared plus beta squared. You have ax squared plus bx plus c equals 0. You have alpha and beta. Alpha plus beta will be minus b over a. Alpha beta will be c over a. This is theory. Now roots with alpha squared and roots which are alpha squared and beta squared. First of all, consider the sum. What is the sum? Alpha squared plus beta squared. Alpha squared plus beta squared is basically alpha plus beta whole thing squared minus 2 alpha beta. If you simplify this, you will have alpha squared plus 2 alpha beta plus beta squared minus 2 alpha beta. This and this cancel off. Alpha squared plus beta squared is remaining. Alpha plus beta squared is minus b over a whole thing squared minus 2 c over a. Simplify. B squared over a squared minus 2 c over a. This is b squared minus 2ac over a squared. Okay. First. Then you should have the product of the equation. Product of the roots. You have alpha squared multiplied by beta squared, that is basically alpha beta whole thing squared. Alpha beta whole thing squared is c over a whole thing squared, that is c squared divided by a squared. Now the new quadratic equation is x squared minus sum of the roots x plus product of the roots equals 0. So x squared minus, what is the sum of the root? B squared minus 2ac. Put a bracket, B squared minus 2ac over a squared x plus product of the root is c squared over a squared equals 0. Then cross multiply, in the sense don't keep a squared in the denominator. A squared x squared minus b squared minus 2acx plus c squared equals 0. This is the new quadratic equation. Next part, show that the roots of this quadratic equation, the new quadratic equation, are both real, if and only if either alpha and beta are both real or alpha and beta are both purely imaginary. Okay. When roots are real, when roots are real, okay, when roots are real, what is the condition? The discriminant should be positive or equal to 0. Discriminant should be positive or equal to 0. In this case, the discriminant of this is minus, okay, b squared minus 2ac whole thing squared minus 4a squared and c squared. Okay, this should be greater than 0. This is going to be b squared minus 2ac whole thing squared minus 4a squared c squared greater than 0. Okay. Now what you have to do is, this is difference of 2 square. You can easily take b squared minus 2ac minus 2ac and b squared minus 2ac plus 2ac greater than 0. This and this cancel off. You will have b squared minus 4ac and here you have b squared outside. Okay. When roots are real, this is the condition. When roots are real, b squared inside bracket b squared minus 4ac should be greater than or equal to 0. The question is, show that roots of this equation are both real if and only if either alpha and beta are both real. Okay. Now, in this particular scenario, there are two cases. Okay, there are two cases. When you consider b squared, okay, when you consider b squared, either b will be negative or positive. Whichever case b is positive or negative, b squared will always be what? Positive. Because it's square. Or else b will be 0, which b squared will become 0. When b squared is positive, to make this whole thing positive, b squared minus, if b squared is positive, b squared minus 4ac also must be positive. B squared minus 4ac is positive or equal to 0. In the previous answer, we can see in this particular here, b squared minus 4ac is greater than or equal to 0 when alpha and beta are real. This is the condition. Therefore, alpha and beta are both real. Answer. Okay. The other condition is when b squared equals to 0. When b squared equals to 0, since we considered b squared minus 4ac is positive here, we will consider the other option. B squared minus 4ac is negative. B squared is 0. 0 means 0 minus 4ac is negative. Minus 4ac is negative. Remove minus 4, ac will become positive. B squared equals 0 means basically b is also equals to 0. B is 0 and AC is greater than 0. Where will this come? When alpha and beta are both purely imaginary. All of these are very logical questions. In previous way we have solved it. This particular part. Here, roots are purely imaginary. Next. This part is done. Now let's go for the B part. B part. Let fx equals x cubed minus 3abx minus a cubed plus b cubed, where a and b are real numbers. A, b are real numbers. Show that x minus a minus b is a factor of fx. To do this, we are going to use factor theorem. X minus a minus b equals 0, x should be equal to a plus b. When x is equals to a plus b, substitute like this. You will have a plus b whole thing cube minus 3ab a plus b minus a cube plus b cube. A cube plus 3a squared b plus 3ab squared plus b cube minus 3a squared b minus 3ab squared minus a cube minus b cube. A cube cancel off, b cube cancel off, 3a squared b minus 3a squared b cancel off, 3ab squared minus 3ab squared cancel off. What is remaining? F a plus b is 0. According to factor theorem, according to what theorem? Factor theorem. X minus a minus b is a factor of fx. Done. Next, find the other factor of fx in a quadratic form. Okay. To do this, there are two ways. Either you can use long division form, or else you can use comparing coefficients form. Both of these methods are usable. Fx is, since this is a factor, x minus a minus b, and the remaining factor should be a quadratic factor because they are telling you ax squared plus bx plus ce. Okay. Now simplify. Ax cube plus bx squared plus cx minus aax squared minus bax minus ca minus abx squared minus bx minus c. This is all equal to fx. Fx equals ax cube, where you have x squared, take all of them together, b minus aa minus ab x squared plus c minus ba minus bb x plus done here minus ca minus cb. Now what is equal to fx? Fx means x cube minus 3abx minus a cube plus b cube. This is equal to ax cube plus b minus aa minus ab x squared plus c minus ba minus bb x plus minus ca minus cb. Okay. Compare coefficients. Compare coefficients. Okay. What will you get? If you compare x cubed as a coefficient, you will have a equals 1. If you consider x squared, it's going to be b. A is 1. A minus b equals 0, which means b equals a plus b. A is 1, b equals a plus b. Then by comparing x, you can have c minus, you don't have to compare x, you can compare x to the power 0. X to the power 0, if you compare minus ca minus cb is equal to minus a cube plus b cube. Take minus out, ca plus cb equals minus a cube plus b cube. ca plus cb is equals a cube plus b cube. Okay. Then you can take c out. If you take c out, you will have a plus b. A plus b equals a cube plus b cube, like this. But this will make it a little complicated. Instead of this, we can also go for x to be much more easier. C minus ba minus bb, c minus ba minus bb, that is equal to minus 3ab, minus 3ab. Okay. we already know what is b. The value of b is going to be a plus b. Okay. C minus, take b out, a plus b equals minus 3ab. C minus, b means a plus b times a plus b equals minus 3ab. C equals a plus b whole thing squared minus 3ab. If you expand this, a squared plus 2ab plus b squared minus 3ab. Basically, C is equal to a squared minus ab plus b squared. Okay. Now, you can say the other quadratic factor. They're asking what the other factor of fx is ax squared plus bx plus c. You know, a is equal to 1, so x squared plus b is equal to a plus b. A is equals to 1, b is equals to a plus b, and c is equals to a squared minus ab plus b squared. Ax squared plus bx plus c is equal to x squared plus a plus b x plus a squared minus ab plus b squared. Okay, this is the other factor of fx. Hence or otherwise, show that if a and b are distinct, then fx equals 0 has only one real root. Now you have fx. Fx you can write as x squared plus a plus bx plus a squared minus ab plus b squared. This is the quadratic factor. You multiply this by x minus a minus b. Then you will get fx. They are telling you to show that fx has only one real root. Now, the real root should belong to this. This already has a root. No, a plus x equals a plus b is a root. Okay. If fx has only one real root, that root will be here, which means this should give you no roots. This should give you no roots. Okay. When will a quadratic term will not give you a root? Quadratic term will not give you a root if the quadratic term is either like this or if the quadratic term is like this, which means the quadratic term is not touching or cutting this x-axis. Basically, quadratic term has a negative discriminant. Discriminant should be negative, not even equal to 0. What is the discriminant here? B squared minus 4ac. So a plus b is here b squared minus 4a. C is a squared minus ab plus b squared. Negative. Expand this. A squared plus 2ab plus b squared minus 4a squared minus into minus is plus 4ab minus 4b squared is negative. Then minus 3a squared plus 6ab minus 3b squared is negative. Okay. Multiply everything by minus, you will have 3a squared minus 6ab plus 3b squared is positive. Take 3 out, a squared minus 2ab plus b squared is positive. A squared a minus b whole thing squared is positive. Now 3 is always positive, a minus b is also always positive, which means this is basically true. A minus b is positive means a minus b squared is positive means a minus b is positive, or a minus b is negative. One of this is true. Okay. When a minus b is positive, a is greater than b, or a is lesser than b. In both of these cases, a is not equal to b. The condition is proved because they are telling if a and b are distinct, therefore a and b are distinct. If a and b are distinct, okay, if a and b are distinct, then the quadratic factor, don't write like that, then the discriminant, let's write delta itself, then cut this, delta is negative, therefore no roots by the quadratic factor. Therefore fx has only one real root. What is that real root? Are they asking that real root also? we will write it, that is x minus a minus b equals to 0, x equals a plus b. This is the real root. Okay. Remember this part, x equals a plus b is the root. Remember this part, this will be useful in the next question. What is the next question? Deduce, which means based on the previous question we have to prove something. Deduce that x cubed minus 9x minus 12 equals 0. This is an equation, has only one real root. Now if you consider x cubed minus 3abx minus a cube plus b cube, these two equations are corresponding. You can see, you can take minus 3ab when minus 3ab equals minus 9 and minus a cube plus b cube is equals to minus 12. 3ab equals 9, ab equals to 3. A cube plus b cube equals to 12. This is equation, let's say Roman 1, this is equation Roman 2. When this is the case, okay, when this is the case, these two equations, x cube minus 3abx minus a cube plus b cube, corresponds with x cube minus 9x minus 12 equals 0. Therefore, since, which means if this fellow has only one root, this fellow also has only one root. Since x cube minus 3abx minus a cube plus b cube equals 0 has only one real root, subsequently x cube minus 9x minus 12 equals 0 also has only one root. What is that root? That root should be, the root will be a plus b. The root is a plus b. Now if you can find a and b by using this simultaneous equation Roman 1 and Roman 2 and add them, you will get the root. Okay. By 1, you can say b equals 3 divided by a. Okay. Substitute this. Substitute into Roman 2. A cube plus 3 over a cube equals 12. A cube plus 27 over a cube equals 12. A to the power 6 plus 27 equals 12a cube. A to the power 6 minus 12a cube plus 27 equals 0. Now you have a to the power 6 minus 12a cube plus 27 equals 0. Let's consider a cube is p. So then this becomes p squared minus 12p plus 27 equals 0. Take two brackets, p times p, 27 means 9 times 3 minus minus. A cube minus 9, a cube minus 3 equals 0. A cube minus 9 equals 0, a cube equals 9. A cube minus 3 equals 0, a cube equals 3. Now 9 plus 3 equals 12, which means you already know a cube plus b cube is equals to 12, which means a cube, when this is true, then this becomes b cube actually. So you can take a cube is 9 and b cube is 3. Okay. A cube is 3 to the power 2 and b cube is 3 to the power 1. A cube is 3 to the power 2 over 3. Sorry, not a cube, a. A equals 3 to the power 2 over 3 and b equals 3 to the power 1 over 3. Okay, this part is done. Now, root of, what is the equation? X cube minus 9x minus 12 equals 0 is a plus b. 3 2 over 3 plus 3 1 over 3. This is the final answer. Okay. We have successfully concluded Pure Maths 2011 part B, question number 11, A part and B part. totally giving you a marks of 150.